So before we get back to taking a look at some algebraic techniques for dealing with the infinite limit, I wanted to talk about some what we might say is conceptual arithmetic. Conceptual arithmetic that you can use when you're trying to determine what the limit is. So just as a quick example, suppose I'm taking the limit as x goes to infinity of x squared plus 3x. Oops. Well, one way to think about that is, x squared is just going to infinity, 3x is going to infinity. So if you sum two things that are going to infinity, it seems like overall that should be going to infinity, and that is true. So what we would say is that you can assume that, or you can state that as true, that infinity plus infinity is infinity, right? So you can say that if you're adding two things going to infinity, then you can conclude that the result is infinite. You do have to be careful. Oh, let's do the other one. Let's do one more that's positive before we go to the negative. So suppose I take the limit as x goes to infinity of something like x squared times e to the x. Then in this case x squared is going to infinity, e to the x is going to infinity. So it does seem like if you're multiplying two things and both things are going to becoming infinitely large, then the product is just even more infinitely large. And so that is the case. And so you can say that if you have something going to infinity times something going to infinity, then you can say that the result is infinite. Okay? Now, you do have to be careful about the following two. Let me not put the examples yet. So careful of these. If you have something infinity minus infinity, that actually may or may not converge. May or may not be a number, be a value. It could be, in other words, what I'm saying is this could be infinity depending on how fast each of these terms is going to infinity, or it may be a number, again depending on how fast things are going to infinity. And so just as a quick example here, suppose that you're taking the limit as x goes to infinity of like x squared minus 3x. Well, again, we can't say that infinity minus infinity is infinity. However, notice that if you do some factoring, right, now you have a product of two things going to infinity, and so in this case you can say that that is infinity. Okay? And so as another example, suppose you have the limit. This is going to be kind of a big example here. We go to infinity of the square root of x squared plus 3x plus 1 minus x. Okay. Now, you should be thinking to yourself, this could be something weird here, because if you think of the leading term of this expression, it's x, the square root of x squared, which is x, and here we have an x. So those things are actually going to infinity at about the same rate, except we are adding the 3x here. So that may change the thing a little bit. So how do you think we're going to deal with this? Go ahead and pause if you want a minute to think about it. Are you back? Does this look familiar? Square root of something minus something. We're going to multiply by the conjugate. And the reason we can do that is because we're adding something like of the form that's infinity plus infinity, and that's going to be easier to work with. That's not going to be an indeterminate form, is what we might call it. Okay, now notice when you do that, what happens is the numerator becomes, do you remember how to do the algebra? A minus b times a plus b. We get x squared plus 3x plus 1, right? Minus the second thing squared, okay, and then divided by this, the denominator will stay the same. X squared plus 3x plus 1. Good. Alright. So now the nice thing is that these x squareds cancel, and we're going to be left with the limit as x approaches infinity of 3x plus 1 divided by the square root of x squared plus 3x plus 1 plus x. Okay, now the last thing we left off on in the last video was to divide the numerator and denominator by the highest power of x. So if you look at this expression, what is the highest power of x? Well, remember that this is the square root of x squared, so that's not really x squared. It is just x to the 1 power, and so let's divide the numerator and denominator by x, and we will finish off the example. Just bring the x in. This one you have to be a little bit careful about. Let's go ahead and take it step by step here. Right? And now let's continue with our algebra, because what I'm going to do next is when I want to bring this x into the radical sign, and so remember that we're going to use the fact that x is equal to the square root of x squared if x is greater than 0, right? So this is a really important observation to make, because now when I bring x into the radical sign, numerator stays the same. Denominator now, I'll go ahead and fill in this step, because now the denominator becomes x squared instead of x, and then I'll go ahead and simplify this one. Good. And now we simplify that one last time. Numerator stays the same. Denominator becomes 1 plus 3 over x plus 1 over x squared plus 1. Good. And now we're ready to take the limit as x goes to infinity. So as x tends to infinity, 1 over x goes to 0, 3 over x goes to 0, 1 over x squared goes to 0. And so what are we left with? The limit as x goes to infinity of 3/2, which is, oh, sorry about that. We don't have to say the limit there. The limit is 3/2, and we're done. Good, so we could not have predicted that, right, from the beginning. So if you have infinity minus infinity, you may get something completely different than what you expect. Okay, and then also what happened when we got to this point, let's see, I guess we could say when we got to this point, right, we had infinity divided by infinity, and so we can't predict what's going to happen with that either. We have to do more work. Okay, so in the conclusion, let's go ahead and come up here with our conceptual arithmetic. Maybe I'll summarize it down here. So you can say infinity plus infinity is infinity, or infinity times infinity is infinity, but infinity minus infinity may not be, I'll say, is indeterminate. It may or may not have a number. If I can spell in my pen here. And same thing with infinity divided by infinity. Okay, good. So that's just some general things to kind of keep in mind as you're going through some of these exercises. Good. All right. And so really the only new technique that we're getting in this section, new technique, is to divide numerator and denominator by some x to the n power. And the reason again that we do that is because that we start getting terms of this form, right? And so we had this form and this form, and those are easy to compute the limit for because they just go to 0. Good. Alright. Let's see, do I have time for one more example? Maybe I better just start off another example in another video. Okay, I'll see you in the next video. We'll do some more examples of taking the limit.